Hello, Simon, Wilden Tools, here today to talk about collets. This mainly refers to collets in CNC machining, but some of the information I'll give you does refer to using collets in your normal router, etc. So, this is a collet. They're made of a high grade of sprung steel. Due to an engineering standard that relates to something from the past, they all have a number on them. In fact, two numbers. This one's a 24 to 25 millimeter. The number we're interested in is always the larger number. So for this collet, it's 25 millimeters. The reason for that is in engineering, they're used in low speeds, and engineers will sometimes crush something into them. They'll crush something less than 25 millimeter in it, but because they're only going 4,000 revs, it doesn't matter. For us, routing at 24,000 revs, it's really important that we don't consider this collet to be a range collet. It is a set size. So this 24 to 25 one is for 25 millimeter shank cutters. Now, that's important for a number of reasons. We want the collet to grip the shank of the router cutter all the way around the shank. That's important because that's what will stop the cutter vibrating, and the vibration causes noise and reduced cutter life. So for us, it's important that we work on the 25 millimeter. Now, at Wilden, we machine all of our router cutters to a tolerance of H6. I won't get into the specification of that, but it's something like a tolerance of 0.03 millimeters. Now, there's no point in us making all that effort to make the shanks of our cutters very, very accurate if you're going to put it in a Chinese range collet. There's no point in making the shanks of our cutters to such a high accuracy if you're going to get that cutter and fit it into a range collet. It's very important that you use a good quality collet so that you know you're getting that grip all the way around. I have known people that these are a consumable item, and I have known people that have carried on using a collet, and they've rung me and they said, you know, these tools, I'm not getting the same life as I was getting before. You know, why is that? And I say, well, when was the last time you changed their collet? They often say, I've never considered changing it. It's the collet, and but they are a consumable item, and if you find you're breaking tools or you've got a reduced tool life, you especially notice if there's something that you make all the time that's always got the same cut. If you notice your tool's not lasting as long, the most likely reason is the collet. If you haven't got a good grip on it, you get vibration, and vibration reduces the life of your cutter. So collets are made from a high grade sprung steel, and they do last. A good quality collet will last a long time, but you should still consider it as a consumable item. Now, I should just basically explain what you will see when a collet starts to wear out. So you will notice if your tool life's reducing. That's one way to work out if your collet's wearing out. And the other thing that you'll probably notice, and you certainly should look for every time you change your tool, is that you'll get, because it's just gripping on for each one of those individual segments, when it starts to wear out, it'll only grip on the middle part. So that will transfer into vibration through the collet, and the vibration will leave a line on the shank of the collet. Now those lines will be basically in the middle of that circle, and you'll see those lines on the shank of the cutter. So every time you take your cutter out, just have a look at it and see if you see any lines that go along the shank of the cutter. If you ever see those, it's probably time to throw this bit away. These are relatively inexpensive. You know, you might be spending £200 or £300 on a diamond tip cutter. You don't want to stick it in a £20 collet that's worn out. You really do want to look to make sure that you're always look for those lines. Look at the collet, just inspect all the parts, make sure they're all right. Make sure when you fit it back in the machine that all those parts are clean, because a speck of dust in there will cause a vibration. The vibration will reduce the tool life. So can I just talk about some bits associated with the collet? Let me just talk about some bits associated with the collet. The nut, we put our collet into the nut, and then we put our tool into the collet, and we do that up in our tool holder or in the bottom of our spindle. And we snug it up with our fingers, and then the next thing we do is we get out our spanner and we tighten that up. We tighten it up as much as we think we need to. And I'll be honest with you, I've seen lots of people doing it, and I've seen lots of people doing it with this spanner. And I know that a lot of people aren't doing it up tight enough. And I know that because I used to be one of them. So we introduced into our range a torque wrench. This has the advantage that you always do your nut up to the same tension, and you always know that it's tight enough. Now, if you compare this with the spanner, you will see why I think I wasn't tightening stuff up enough before. It's considerably longer, but being torque limiting in effect, it stops you over tightening, elongating, damaging anything. So this just gives you some reassurance that you are doing it up to the correct tension. Now the other thing to think about is the nut itself. So this is a standard nut. When you tighten up with a standard nut, as this grips in your tool holder and the nut is gripping on this taper here, and as you drive them round, when you get to the last bit of tension, you have to overcome all that friction. Now we do a nut that helps you overcome that. This nut has I don't know if you can see this on the video, but this nut has a bearing in the end, and as you tighten the nut, you can see that the collet stays still, but there's a ball race in the end of here that really does allow for consistent tightening, and you're not trying to launch those two components against each other, so it looks after all the components within here. Now, we're not talking a lot of money for a nut and a collet. They're relatively inexpensive things, and if you compare those to the cost of, you're going to put a diamond tip cutter or a tungsten carbide cutter in there, that's a considerable investment, and really you want to make the best of your investment. So these things are very well worth considering. These will improve tool life, they will improve noise because they'll stop vibration. So the only other thing that I haven't talked about is actually inserting the tool into the collet. Now this is a bigger collet, and it doesn't have the relief on the back of the collet. Most of the smaller sizes have a little relief in there. We all know what the K line is. It's the line the minimum insertion point. But what you also need to make sure is that where you insert the cutter, that it does go to the end of the narrowest point of the collet, and it needs to meet all of that, so that when you grip it up, you're not trying to distort the collet. So I've chosen this larger collet because it's cylindrical all the way through. You could imagine if I only put it in halfway, this side remains large around the collet, and then as you screw it up, the inside is trying to get, it almost tries to screw it up and turn it around. Now if you ever do that by mistake, that destroys the collet. It does, even though they're sprung steel, it will distort the collet, and it does destroy them. So it is important that you fit the cutter all the way up to the end to ensure that you don't destroy the collet. So there's one more sort of wear that you can look at, and it's distortion within the collet. Now this was sent to me by somebody else, and I don't really know what happened to it, but we have seen this before where you get this kind of, I don't know if you can see that, but there's a bit of distortion in the end of the collet. So when you change your cutter, just feel around where the cutter fits in, and if you can feel a raised lip there or any kind of distortion there, it's time to chuck it in the bin, because there has been some kind of metal flow there. These are under a great deal of load, and I think that is probably, it's a guess, but I think that probably is what happens to these collets when they start to wear, is the metal actually flows and the shape of the metal distorts, even though they're a high grade sprung steel. Before I go, there's one last collet to mention. This is our 4-grip collet. It has less slits in it. It's machined specifically, doesn't have a range marked on it. You'll see this one just says 10. The reason for that is this has to be used specifically with exactly the right size component to go in it, or it won't grip. And it has to be done up to the right torque, and you have to use a bearing nut. But they do give superior holding over the other collets. They do reduce vibration, and you can hear that when you use them. They especially work well with the smaller diameters, so anything from 1/2 inch to below. I've got a 8mm shank cutter that I use a lot, and I specifically use that with a 4-grip because it's a combination spiral, and it's very noisy without it. Anyway, I hope you got some information out of this video, and I hope that it helps you. So if you enjoyed it, or at least if you got something out of it, please consider pressing the subscribe button so you can see more videos in future. But thanks very much. Bye bye.